On question number 8, we want to list the 5 ways to prove triangles congruent. And so side, 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 angle, side, angle, side, angle, 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 side, and then HL. On number 9, which way could I use to prove these two triangles congruent? Notice I'm given AC is congruent to FD, so I'll mark that. AC is congruent to FD. I'm also given that AB is parallel to DE. Well, I'll use this transversal because parallel lines don't mean they're congruent, but it means angles are congruent. So we know angle B is congruent to angle E. And I'll use my other set of parallel lines. AC is parallel to FD. So then what I want to do is I'll say, oh, my alternate interior angles, angle C is congruent to angle F. Now, what makes these two triangles congruent? Well, notice the side is not between the angles, is it? It goes angle, angle, side in each triangle. So the reason these two triangles are congruent is angle, angle, side. And here's a proof that's partially done for us, but not the whole thing. We're going to have to fill it in. We're told triangle ABC is isosceles with base AC. That's our given. Because it's isosceles, I know AB is congruent to CB. Let me mark that down here. AB is congruent to CB because we know it's an isosceles triangle. Therefore, angle A is congruent to angle C. Why is angle A congruent to angle C? Well, because they're base angles of an isosceles triangle, which normally we call the isosceles triangle theorem. Then we're given D is the midpoint of AC. Remember, midpoint means it goes right through the middle. I'll put 2 tick marks on there to show their difference. And so that's where we get AD is congruent to CD, reason, definition, and midpoint. Then we're told triangle ABC is congruent to triangle CBD. Why is that? Well, notice what we have here. We have side, angle, side. So side, angle, side. Then we're going to say angle 1 is congruent to angle 2. And angle 1 is congruent to angle 2 because they're incongruent triangles. That's CP, CT, C. And since angle 1 is congruent to angle 2, that tells me BD bisects angle ABC by the definition of an angle bisector. On question number 11, we want to find X. Notice this is an isosceles triangle. It's an equilateral triangle, which means all my angles are equal. Or all my angles actually equal 60 degrees. I could do any one of these equal to 60 to solve for X. I think I'll do 21x minus 3 because that seems like the easiest to work with. So we're going to say 21x minus 3 equals 60. Well, what then I want to do is I'm going to add 3 to both sides. So 21x equals 63. Divide both sides by 21. X equals 3 is our solution. And that's all you would have to do to solve that question.